All right, first off, what's the formula? What is this one looking for? You might as well get your notes out also because you have nothing in front of you. What is this one? It's the slope. What's the formula for a slope? Change of y over change of x. The formula is y2 minus y1 over x2 minus x1. You have to know the formulas. This is a math course. What's the second one looking for? Midpoint. Remember, it's a point. It's a location. So you have to have an x and y. So what's the formula there? And the distance formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. We did exercises of this. We talked about these, and these are just plotting points. So this is x1, this is y1, because that corresponds to point 1. This is point 2, so this is x2, and this is y2. Y2 is -3 minus -5. Those become a positive. Two negatives become a positive. X2 minus x1. So -3 plus 5, positive. 5 minus 3 is 2. They're both negative, so the answer is negative. 5 plus 3 is 8. So the answer is -1/4, because 2 goes into 2 once, 2 goes into 8 4 times. So that's your slope. X1 plus x2. We have 3 plus -5 over 2. -5 plus -3. So this becomes a minus. So 3 minus 5 is -2 over 2. -5 plus -3, they're both negative, so I add them. So the answer is -1, -4. That's the midpoint. X2 minus x1, we did that up here, is -8. So it's -8 squared. Y2 minus y1 is 2. -8 times -8 is 64. 2 squared is 4. So the answer is square root of 68. So far, with what I was looking at, only one student got them all correct. Who else thinks they got theirs correct? Here's another one. And hopefully nobody missed this last one. The point is +3, -5. 1, 2, 3, 4, 5. Then -5. 1, 2, 3, 4, 5. -3. And And there's the graph. It wasn't that much that we covered last time. So let's continue. Let's finish up section 1. Intercepts. Intercepts are where the line crosses the X and Y axis. So let's say we have a graph and it looks like this. The x-intercept what's the location of the x-intercept in this graph? Just -3? It's a location. It's a point. Right. So the location of this one is -3, 0. What's the y-intercept? 0, 3. This gives us what we need to know. How do we find the x-intercept? Set y equal to 0 and then solve for x. So you'll always end up with an x value and your y value is always 0. That's the x-intercept. Bless you. What do you think you do for the y-intercept? Set x equal to 0 and then solve for y. It's always going to be 0, y. Now, why do we use the x and y intercepts? Because that's another way we can use to graph these things. Because if we can find the x-intercepts, once we have our 2 points, connect them and we're done. So example 3. Graph this equation. 2x plus 3y equals 18. So the first thing we're going to try to find the x-intercept. And then we'll try to find the y-intercept. Because if we can find those, then it's an easy graph for us. So we have 2x plus 3y equals 18. 2x plus 3y equals 18. To find the x-intercept, what I have to do first? Set y equal to 0. Anything times 0 is, so it just pretty much erases it from the board. So all we have left is 2x equals 18. So what's my x value? We have to get x by itself, so we have to divide both sides by 2. X equals 9. So my x-intercept is at 9, 0. The same thing for the y-intercept, but this time we set x equal to 0. Two times 0 is 0, so it disappears. 3y equals 18. Divide both sides by 3. 18 divided by 3 is 6. So my y-intercept is at 0, 6. Or I plot those 2 points at 9, 0 and 0, 6, connect the dots, and I'm done. There's my graph. Will it always be so easy? No. If it gives you solid numbers, it's great. Example 4 says graph this equation. 3x minus 5y equals negative 10. So we look for the x-intercepts and y-intercept. Negative 10. 3x minus 5y equals negative 10. Repeat the process. For the x-intercept, we set y equal to 0. So that makes that disappear. And divide by 3. Since we're graphing, and also this is a rule of mathematics, what kind of fraction is this? If the top number is bigger than the bottom, it's an improper fraction. Because the top number is larger than the bottom. How many times does 3 go into 10? 3 times. With how many left over? 1. Since 10 divided by 3 is the same thing as that. 3 goes into 10 3 times. 3 times 3 is 9. This number goes out in front. This number goes on top. And this is always your bottom number. What kind of number is this? Starts with an M, ends with ixt. Mixed number. Because it has an integer and a fraction. This is called a mixed number. Whenever you have an improper fraction, you're supposed to always put it as a mixed number. Because notice the top number always has to be smaller than the bottom. Can we graph that number? Yeah, it's going to be difficult. Because -1, -2, -3. So it's -3 and 1/3. It's right about there. But it's not precise. This is -3 and 1/3. So if it doesn't come out as a whole number, then we're going to look at another method. How do we find the y-intercept? Set x equal to 0. So that disappears. So I have -5y equals -10. I'm going to give you some free advice here. I know what you guys would do here at this stage. To get y by itself, what are you going to do? You're going to divide by what? Well, because there's a -5. Now, if you divide by -5, you're going to have all these negative signs and signs everywhere. That's out of anything in mathematics, what makes most students fail exams is that little symbol right there, that negative sign. It's going to show up where you don't expect it. It's going to disappear when you're trying to write it. It's just going to ruin your day. Most mistakes will happen because of that negative sign. So because of that, never divide by a negative number. Remember I told you last time, treat the numbers and the signs differently. -5y equals -10. First off, we have to get rid of this negative. So first off, across the entire equation, change all the signs. This becomes a +5. This becomes a +10. I'm doing the same thing across, so nothing's changing. I'm just changing the way it looks. So first off, get rid of the negative. Now we could just divide by 5. We don't have to worry about negative signs anymore. 10 divided by 5 is 2. So approximately there is your graph. So whenever your last step has a negative in front of your variable, change all the signs across the equation first and then divide. I know it's trying to change what you've been taught for so many years, but you were taught the wrong way for many years. More mistakes will happen that way because you're going to forget, or you're going to put a negative, it's just going to disappear, something's going to happen. So it's just reduce the chance of mistake by keeping the signs and numbers separate. Any questions about that one? All right. Now, example 5. It says graph this one. I know why they're putting it in there, but they haven't introduced what kind of equation is this? Because everything we've done so far are, if you draw the graph, what does the graph look like? They're a line. Everything we've done so far, because when we graph them, they're a straight line, those are called linear equations. There's no exponent, there's no square root, there's nothing. This one, because it has a square there, this is what's called the degree. This is called a quadratic equation. The degree tells me how many answers, how many solutions I can have. The degree tells us the maximum number of solutions possible. Now, in that statement, we just defined degree. It's the maximum number of solutions possible. There's only one word in there that we have to define. When we say solutions in mathematics, what does it mean? What's that? Not the plural. Which intercept? You're right, but which intercept? 50-50 shot. It's the x-intercept. Whenever we talk about solutions, we're looking for the x-intercepts. So the word solutions and x-intercepts are the same thing. We can also call them zeros. We can also call them factors. We can also call them roots. So the word solutions, whenever you see that in an equation, that's what it's looking for. We want to know where the graph is going to cross the x-axis. So obviously we have two of them. You'll note you can have at most one y-intercept. Given a function, you can only have one y-intercept. So what is the y-intercept of this equation? Very good. The y-intercept is always the constant. The y-intercept is always the constant of an equation. Why is that? Think of the steps. How do we find the y-intercept? Set x equal to 0. So if we put 0 in place of x, that disappears, that disappears. So all we have left is our constant. So that's always easy. But now, because the degree is 2, that means we can have two x-intercepts, two solutions. What is this graph going to look like? Or, yes, this equation, because it's quadratic, it can look like this, or it can look like this. Whenever you have an x squared, it's going to be one of these two. In the next couple of class periods, I'm going to show you how you can just look at the equation and you can tell me roughly what the graph will look like. Because how do I know it's going to be this one and not this one? Right. Because there's supposed to be a number in front of here. Right now, it's what? It's positive 1. If the coefficient of x squared is positive, then it opens up like this. Here are our x-intercepts. If the coefficient is negative, then it's going to open down. It points to the negative realm. Now, the question you may have is this. Quadratic equations can have at most 2 x-intercepts or solutions. Quadratic equations, if your degree is 2, then you can have at most 2 solutions. Why? Why is it at most 2 solutions? Because 1, it could look like this, where you have 2 solutions. What if it scoots up and it only touches at one place? There's 1 solution. This is 2 solutions. This has 1 solution. And this, it looks like this, has 0 solutions. Or I should say 0 real solutions. We'll talk about that later. Meaning, if you have a graph like this, that means your answers are going to be square root type equations. There are roughly around 12 or 14 basic functions that we're going to talk about in the next couple of days. And you're going to know, if you just look at the equation, what the basic shape of the graph is going to be. So knowing that, you know what you have to look for. So basically, for right now, we can't solve that, because we haven't learned the quadratic formula or the quadratic method yet. That comes mostly in next chapter and in chapter 4. Any questions so far? So far we've talked about the slope of the equation, the midpoint, the distance between 2 points, and finding the x and y intercepts. Let's talk about equations of circles. Equation of circles. Equations of circles. And this is the interesting part about circles. First off, how would you define a circle? We have to know what we're looking for, so how would you define it? Don't give me that wedding thing of it's something that never stops and never ends, it goes on forever. You know, you got the ring. So don't give me that example. That's not what a circle is. So is a square. No, with that, we start narrowing it down. Okay, it's geometric shape. What do we know about it? Has no points. Does it have any angles inside it? If it has no points, there are no angles. Would you believe that even though that's true, that it's just the opposite? What's the opposite of no? No, instead of no. How many? Infinitely many. A circle, here's a circle. An infinite number of points that are all equidistant from a center point of the circle. It's an infinite number of points that are all equidistant. Equidistant. So what does that mean?
Then you have a pretty put the line from the filters on the.
Okay, yes. So let's look at this. We have a circle. Any point, here's a center, it's the same distance. It's the same distance. What do we call that distance? The radius. Very good. So this equidistant equals the radius. Now, here's the interesting part. The equation that we're going to use to define a circle is a triangle. If you think about it, this is the radius, but it could make a triangle. This one, it could make a right triangle. Each one of these points on the graph, I can make a right triangle. And the more of these right triangles I have, the more points I have, eventually what happens? Instead of being triangles, it now becomes a smooth curve. So do we have any formulas that we could deal with triangles? What? What formula do we know about triangles? What's that called? The Pythagorean theorem. To define the equation of a circle with a center at HK and radius R. So we use the Pythagorean theorem to define the equation of a circle with a center at HK and radius R. So that's C squared equals A squared plus B squared. Remember, This is A, this is B, and that's C. So looking at our pictures here, this is going to be our center, HK. A deals with the change of X values. B is the change of the vertical values, the Y values. And that would make C is equal to what? The radius. So let's fill this in now. Here's Pythagorean theorem. The hypotenuse is the radius, so it's r squared. A is the change of x, which is x2 minus x1 squared. Y2 minus y1 squared. But look at our picture. All of these triangles have this as the same point. So that's the x1, y1 value. So instead of using x1, y1, I now will put, in place of x1, I use h. In place of y1, I use k, and there's my formula for a circle. So here's the fascinating thing. This is still the Pythagorean theorem. The Pythagorean theorem is how we define triangles. But we use triangles to define a circle. So a circle is an infinite number of right triangles that keep on going forever and ever and ever in the circle. So let's look here. Let's look at example 10. Find the equation of the circle with radius 5 and center at 3, -7. So far, so good? So we have to do, remember, like we learned in the first part, to find the mean, the slope, the midpoint, and the distance, we have to label x1, x2, y1, y2. So what is r? 5. What is h and what is k? 3, -7. Because that's the center. HK is the center. Since it's asking us to find the equation of the circle, it says in the question, find the equation of the circle. So that tells us we have to use our equation, r squared equals x minus h squared plus y minus k squared. The question tells us what formula we have to use. Now we just plug and play. R is 5. X minus h is 3. Y minus -7 squared. 2 negatives become a what? So 5 squared is 25. x minus 3 squared plus y plus 7 squared. There's your equation of a circle. Yeah. Yeah. Let me do another one. Example. Given the equation of a circle, 16 equals x plus 2 squared, y minus 3 squared. Find the radius and center of the circle. Okay, now how do you approach this question? Well, first off, we know we're dealing with the equation of a circle. What is the formula for circle? R squared, x minus h squared, y minus k squared. So what we're given is 16 equals x plus 2 squared, y minus 3 squared. So r is equal to what? And the center is equal to what? R is equal to the square root of 16. Because remember, this is r squared. So r squared is equal to 16. I'm looking for r. How do I get rid of the square? Square root both sides. So the square root and the square cancel. So what is the square root of 16? So the radius is 4. And the center is what? Just the opposite. -2, +3. Whenever you're solving for something inside parentheses, it's always the opposite. So if this is +2, the answer is -2. If this is -3, the answer is 3. Here's the reason why. What does h and k represent? The center. So x and y tells us how far from the center that number is. So what we're looking at is we want to find h and k. So what do we have to do to get back to 0, 0? So if we take this equation, set it equal to 0, and we take this equation, set it equal to 0. So that gives us -2 and +3. That's why whenever you solve for anything inside parentheses, it's always the opposite sign. Because we want to know how far is it from 0, 0. Now, given this circle, find me the radius and the center. What's the radius and what's the center? Okay. Remember, this is the equation of a circle. So what's the formula for a circle? R squared equals x minus 8 squared y minus k. So always start off with what the equation is in the question. And in our example, we have 5 squared equals x squared plus y plus 3 squared. So what's our radius? It's just 5 because they're both squared. So that means r is whatever's there. If there's no square, then we have to square root it. If there's a square on the radius, then we just take whatever's underneath the square. Yes. Yeah, and that's the short. If in your equation, if the radius is not a square, if it doesn't have the square symbol on it, then we have to take r squared equals that number and then square root both sides. If it has a square on it, then r is whatever it is, whatever the number is. So what's my h and what's my k? 0, because there's nothing there, and -3. Very good. What's my radius? What's my center? What's the center? Yeah. The center is always the opposite of what's inside there. If that's a +2, the answer is -2. If it's a -2, the answer is +2. But are we done? No. What's the square root of 1? If you can go further, go further. If you can simplify, always simplify. Find the equation of a circle given the radius equals the square root of 5 and the center is at -3, 0. What are we looking for here? Equation of a circle. So we're looking for an EOC. That formula is r squared equals x minus h squared plus y minus k squared. Plug them in. R is square root of 5. So it's square root of 5 squared x minus -3, because this is h, and that's k. Y minus 0 squared. Are you done? No, because you can do something else. What can we do first? The square root and the square do what? They cancel. So it's 5. The two negatives becomes a positive. Y minus 0 is just y, so it's y squared. Math circles. Pretty easy. Unfortunately, it's 10 minutes before we get out of class. So we can't really start the next section. So I need to set you guys free for the weekend. Sad. I know, hold your tears back.